Hello and welcome to section 4.5. We're going to be working with a couple more shortcuts today. In the meantime, here are your answers to 4.4. You guys had a lot of proofs. Keep in mind sometimes the order of your proofs are going to be different, and that's okay, especially for these proofs here because you're showing that different parts are congruent, and the order can be changed for a lot of the different parts. For example, like let's say number 4, if you wrote reflexive anywhere up here, like that's okay. And then a couple more proofs. And one more proof. If you guys have any questions on how to do any of these proofs, make sure you guys see me during work time so I can assist you. We're going to be working with angle, side, angle today, and angle, angle, side. I'm not going to do any type of diagram or any type of explanation for this. You guys have seen a lot. If you guys need an explanation in class, I can do that. Angle, angle, side is actually going to be a theorem. And so we're actually going to prove that one using angle, side, angle. So the first one's a postulate, angle, side, angle. The side has to be the included side. So just like side, angle, side with the included angle, angle, side, angle has to be the included side. And then we have angle, angle, side. We're actually going to use side, angle, side to prove this here. So this goes angle, angle, and then side. So it's the non-included side. All right, we're given a lot of stuff. So we're given the hypothesis stuff. So given all of this, that's what we're given. We're trying to prove the two triangles are congruent. Okay, so what I'm going to start is saying that angle B is congruent to angle E, and that is our third angles theorem. If two angles of one triangle are congruent to two angles of another triangle, then the third angles are congruent. And then the triangles are congruent because of side, angle, side. Or sorry, angle, side, angle. Angle, side, angle. All right, so triangle ABC is congruent to triangle DEF. Want to make sure the order is correct there. Side, angle. No, sorry, I'm getting this all mixed up. Angle, side, angle. If you want to put postulate because it is a postulate, you can do that. We don't need to prove that one. So there you go. That's a short, easy proof. Can the triangles be congruent with the given information? If so, state the postulate theorem you'd use. Make sure you mark down anything in the picture that's true, like those are vertical angles there. So this one would be angle, angle, side. That one works. This one is no. We do not have angle, angle, angle. Angle, angle, angle doesn't work. This one we have a reflexive side right here, and we have angle, side, angle. So that would be yes. So if they don't mark something down that you can mark down, like I marked the vertical angles in the first one and the reflexive in the third one, you want to make sure that you mark those down. Okay, before doing this, watch Mr. Drexler's theorem. I created a theorem that kind of is like the congruent supplements theorem, but it comes up a lot. And so a couple years ago, I made up a theorem to make lives easier. And this is an example. So watch Mr. Drexler's theorem before this, because there's a step in here that uses a theorem that I proved that's not in your book. Okay, so CE is perpendicular to BD, so those are going to be right angles there. CAB is congruent to CAD there, and they want us to show that ABE, so these two are congruent, those two triangles there. Okay, it says flowchart. You can ignore that. If you want to see what a flowchart is, check your book, or I can show you if you're really curious, but it's irrelevant. We're going to do a two-column here. So I'm going to start with, we'll just start that CAB is congruent to CAD, and that's given. And we also know that I'm going to actually going to give these numbers. It's going to make this go a lot quicker. We're going to call this 1 and 2 and 3 and 4. So I'm going to say that angle 1 is congruent to angle 4. and then, or sorry, 3. And then I'm going to say that angle 1 and 2 form a linear pair. As well as angle 3 and angle 4. And that's given / diagram. Now, my theorem that I prove says if two angles, if you have two sets of linear pairs and one angle is congruent to the other angle, so in this case 1 and 3 are the same, and then 1 and 2 form a linear pair and 3 and 4 form a linear pair, then angle 2 is congruent to angle 4. And this is my theorem that I created. And I gave it another name in the video, but that's what I'm going to go with. Okay, so if these two angles are the same here, and I'm going to call this right angle 5 and angle 6. I'm now going to introduce my perpendicular part. So we have CE perpendicular BD. And that's given. And because of that, angle 1 and angle 2 are right angles. Definition of perpendicular lines. And then as a result, angle 1 is congruent to angle 2. Sorry. Those are not. That's 5 and 6. What am I doing here? I'm going to erase that. Okay. Angle 5 and angle 6. Okay, so that's the right angles congruency theorem. First I stated that they were right, then I stated that they're congruent. Okay, I've got two angles, 2 and 4 and 5 and 6 are congruent. Now I just got to say that the reflexive side, AE, is congruent to itself. So AE is congruent to AE. And that is reflexive. And now we have our angle here, we have our angle here, and we have our side here, and it matches up that it is angle, side angle. So triangle is congruent to triangle, and then angle, side angle. So there you go. This is a kind of a more complex proof because there's two triangles within it, and it's not as direct as some of our other ones are. But there you go. So that's using angle, side angle, and a proof. Here is your homework. Again, there's going to be a lot of proofs. You can use a 2-column proof for number 5. At 25, it says flowchart proof, but I'm okay if you use 2-column. Thank you guys for tuning in.